So, you heard that matter exists and is made of particles, and you wonder what is antimatter? This video is made for you. In less than 5 minutes you will know everything there is to know about antiparticles. For that we need a quantum theory, and since quantum particles tend to delocalize, fields that give a number to any point in this dimension, this dimension, this dimension, and time also, might be a useful tool to study particles. And because real numbers are not good enough, take two fields and make a better one. And that's a complex field. Now we can use Lagrangian mechanics and build the action, and let's put in it only Poincare invariant terms so we have a relativistic theory, and that's always handy. So the kinetic term of the Lagrangian should be made of derivative of the field, and with two of them we have a Poincare invariant term. For the potential term, the field and its conjugate just make the job, and with the mass squared as a factor, it has the right dimension. So we have the action and we know that it should not vary, so this, which means this, should be 0. And yes, you saw it, that's a wave equation. And that's cool because waves are cool. Look, that's a wave. That's a wave, and let's say it's true most of the time. But anyway, to solve the wave equation, this works with p squared equal m squared, and well, that works too. Even that can work with p squared equal m squared, which means that, which is satisfied by all p1 possible, all p2 possible, and all p3 possible if p0 is the energy. And since you don't want to make any jealous, well, take all of them. Then look at the action, it has a symmetry. A phase doesn't change the action, and symmetries are great because Noether tells us that it implies a conserved quantity Q, here better known under the name of electric charge. So let's go, we take phi of the field, quantize it by promoting it to an operator. So they become operators too. And put it in this equation, apply the time derivative, and after distributing everything, we find everyone's favorite delta function that imposes the norm of p to be the norm of q, so the energy are the same, which annihilates half of the term, the time dependence in the exponential, and the whole integration over q. To avoid catastrophe, we have to invert those two terms because vacuum is not charged, so we better use normal order here. And here we get a family-friendly video where we see the creature of quanta of the electric charge, and that's a charged particle, with the annihilator, and some other creature of quanta with the same momentum, the same energy, the same mass, but the opposite charge, and that's the antiparticle. I hope you learned something. If you didn't, well, just pretend you already knew everything and send this video to your friend, and I'll see you next time at some corner of the multiverse.